All right, welcome to lesson 7. Today we're going to be talking about one application of a functions called average rate of change. This is something that you have done. It connects to slope. It connects the idea of changing in time and temperature and things like that. And so we're really bringing a lot of what we talked about before together, but also another way of looking at functions in our application. And so today's learning objective is when I give a graph of a function, I can estimate and calculate the average rate of change between 2 points, right? We're talking about a relationship between 2 different points. Our vocab word today is average rate of change. And so this is a nice and short activity, but the goal of this activity is to get you comfortable with an application of a function. And so we're talking about the idea of temperature initially. Here's a table. In 7.1, you're asked to find a recording. Here are 3 recorded temperatures at 3 different times on a winter evening. Tyler says the temperature dropped faster between 4 p.m. and 6 p.m. May said the temperature dropped faster between 6 p.m. and 10 p.m. What do you think? What do you think is more correct? Remember, when we talk about temperature dropping faster, we're talking about it's getting colder at a quicker rate. So think about, is it getting faster? Is it getting colder from 4 to 6 or 6 to 10? And explain what you mean. And so here is a more complete picture of what is happening with our table. And so this is a lot going on here, but what we can slow down and think about it one step at a time. So if I have, let's say I have my 2 points that are from the graph. Let's say I'm looking at my input value of 4 and my output value of 25, which is this point, which is 4 hours since noon. So at 4 p.m., the temperature I know is at 25 degrees, right? My input here is my hours, as you can see, and my output here is my temperature. And so if I'm looking at the relationship between 4 and 25, I can also look at, let's see, I have my relationship between, let's see, this point is 10 hours since noon, which is 10 p.m. And at 10 p.m., I have a temperature of 8 degrees. So think first, okay, how did the temperature change between 4 and 10 p.m.? Did it get warmer or did it get colder? And so the question then is, how much did it fall? I know that it's falling at I know that we started off with 25 degrees at 4 p.m. and then we go down to 8 degrees at 10 p.m. So that is a change of 17 degrees, right? I know from 4 p.m. to 10 p.m. it is a change of 17 degrees. So from here to here, we have a 17 degree change this is in Fahrenheit, right? That because our temperature is in Fahrenheit. And so the question then becomes, how can we tell how fast we are falling? How fast is the temperature falling? And so we know that it's falling 17 degrees, and I know that the length of time it's falling is 17 degrees in 6 hours, right? Because from 4 p.m. to 10 p.m. is 6 hours. And so if I want to find the constant rate at which my temperature is falling, I know to find the average rate of change, I can divide my temperature over my time, right? 17 divided by 6, which would give me my temperature change per hour. This is around 2.8 degrees Fahrenheit per hour. Right, I want to find out at each hour what is my average rate of change. So if I am decreasing from 25 to 8, I'm decreasing at a degrees of 17 degrees Fahrenheit, and that is in a time interval from 4 p.m. to 10 p.m., which is 6 hours. So if I want to find the average rate of change, I'm going to divide my temperature difference in that time over my difference in time. And so if this sounds familiar, we are calculating an idea of slope, right? My slope is changing from what is my average rate of change between these values. And so for those of you who've taken physics, right, we talk about our change in x, right, our delta x, our change in our y value in this case. Actually, our temperature is our y value. Our change in our y value divided by our change in your x value, right? My change in my x, my difference in my x. And so you can use that idea to help you find the average rate of change between noon and 1, between noon and 4 p.m., and between noon and midnight. And so think about how you can first brainstorm on the first slide about what it means to drop faster and slower. And then on the next slide, I want you to take that time to actually calculate what is the difference? What is the average rate of change? And what does that represent? Right? We're decreasing at a rate of 2.8 Fahrenheit. Right? In this case, you could be even more specific that the difference is not only 17 Fahrenheit, but we're decreasing by 17, so it's going to be negative 17, right? 25, we are doing 8 minus that 25 because I'm ending up at 8 and I'm starting at 25 degrees. So we've decreased 70 degrees Fahrenheit. And so that is really the main part of this lesson. So I want you to continue to use that idea when we're talking about populations in California and Texas, and if you need to increase your size as well, right? Find those points when we're finding the average rate of change and making sure you show your reasoning. Think about what does the average rate of change mean in this context, right? In this context, we are talking about temperature per hour. What does it mean when I have population in millions and years? And then answer this question that goes parallel with the question right before. How quickly is it changing between 1990 and 2000? And that finishes our short lesson up. You have, of course, your average rate of change in your summary here. So if you need to see it graphically or you need to see what's going on, there's our further representation. So we'll be getting into lesson 8 and moving deeper into our idea of functions, but this really starts to give you at least an application of how functions are used in our daily world and how they can be used to model situations and further our understanding of our world around us. So I will see you all in